Hey, welcome to another video. This time I'm actually using my whiteboard instead of my iPad, trying a different form of teaching, trying a different form of solving these problems on a video platform. And hopefully one day I can get into some different kind of tutoring, or teaching, and just trying out different methods. But anyway, this video I'm going to be solving the section 6.2 from differential equations and the textbook that I'm using by Zill. Section 6.2 is solutions about ordinary points using power series for a differential equation. And so this is the differential equation that we're going to be solving, that I'm going to be solving today. It's x minus 1 times y double prime minus x times y prime plus y equals 0, subject to the initial conditions, y of 0 equals -7 and y prime of 0 equals 5. And the goal is to solve the differential equation and put the two solutions, y1 and y2, into a standard polynomial form. I think that's what the instructions say. Format your final answer as an elementary function. So the first thing we're going to notice here is that there is going to be a singular point at x equals 1. We might use that later on, so we'll just write x equals 1 is a singular point. So far in the homework, I haven't had to kind of deal with singular points in these equations, but it might come up in the future, so we'll just keep that there because we might have to use it. So the first thing we do is we assume that it has a power series solution, which means we're going to set y equal to the infinite sum from n to infinity of c sub n times x to the n. And then we differentiate this. So we're going to be left with the infinite sum from 1 to infinity of c sub n times x to the n minus 1. Then again, y double prime equals the infinite sum from n equals 2 to infinity from c sub n to n times n minus 1 times x to the n minus 2. c sub n times n minus 1 times x to the n minus 2. And now we just plug these back into the original equation. So it's x minus 1 times the infinite sum from n equals 2 to infinity of c sub n times n minus 1, x to the n minus 2. And this is going to be a long video, by the way, if you can't already see by the timestamp, because these problems take a long time to solve. Minus x times the infinite sum from n equals 1 to infinity of c sub n times x to the n minus 1 plus the infinite sum from n equals 0 to infinity c sub n times x to the n. All of this equals 0. And now we distribute the x minus 1 and to this term. So we're going to be left with two infinite sums. The first one is going to be the infinite sum from n equals 2 to infinity, c sub n times n minus 1 times x to the n minus 2 times x, which is x to the 1. So adding exponents is n minus 1. And then we distribute the negative 1. So it's going to be a minus infinite sum of this entire term right here. c sub n times n minus 1 times x to the n minus 2. Now we distribute this x in there, so it's going to be minus the infinite sum from n equals 1 to infinity of c sub n times x to the n plus this last infinite sum, n equals 0 to infinity, c sub n times x to the n equals 0. And now we can this is the step where we find k. So we let k equal n minus 1, and then we solve for n. So n equals k plus 1. And we're going to do that for each infinite sum. each time letting k be equal to the exponent of x. N minus 2, and then solve for n equals k plus 2. K equals n equals k. K equals n equals k. And now we rewrite these infinite sums going from k. Now, whenever we try to let this equal k, if n equals 2, then we plug 2 into this k equals n minus 1, and we get k equals 2 minus 1, so k will start at 1. And then everywhere we see an n, we replace it with this n right here. So it's going to be c sub k plus 1 times k plus 1 times k plus 1 minus 1, which is going to equal just k. Then we have x to the k minus the infinite sum. This time it's going to be k equals, well, if n equals 2, that means k equals 2 minus 2, which is 0. C sub n is c sub k plus 2 times n, which is k plus 2, times k plus 2 minus 1, which equals k plus 1. Times x to the k minus the infinite sum. K equals, well, k equals n equals 1, so k equals 1. C sub k times x to the k plus one more infinite sum, starting at k equals, well, n equals 0, so k starts at 0. C sub k times x to the k equals 0. Now I'm going to erase this. I'm going to erase starting from up here. And then we'll just continue on from the bottom of the board. Now at this step, we have to let all of the k's begin at the same number. So this number is k equals 0, this one is k equals 0, and both of these are 1. So for these two infinite sums, we're going to plug in 0 to each of them, and then we're going to let the first sum, the first term, add itself up. That way we can combine all of the infinite sums. It's going to look like this. The infinite sum of k equals 1, c sub k plus 1 times k plus 1 times k times x to the k minus the infinite sum. Now in this term, I'm going to plug in k equals 0 because I want the k to be 1. That way I can combine it with these two. So let's just copy down the equation again. C sub k plus 2 times k plus 2 times k plus 1 times x to the k minus another infinite sum of k equals 1. This time I'm copying down this equation. C sub k times x to the k plus the infinite sum. And now I'm going to start this one at 1, and I'm going to plug in 0. C sub k times x to the k. And now let's plug in this term. So first of all, it's going to be a minus because there's a minus sign here. Plug in 0, it's going to be c sub 0 plus 2, which is c sub 2, times 0 plus 2 times 0 plus 1, which is 2, times x to the 0, which is 1. So it's going to be minus 2c2. Then we plug in 0 for this term, so we have c sub 0 times x to the 0, which is c sub 0 times 1, or plus c sub 0. And all of this equals 0. And now we can erase these steps. And so now, let's combine all of the infinite sums into one. So we're left with 1 infinite sum from k equals 1 to infinity. I'm going to use a bracket, and then we just copy down each of these terms, but then we take out an x to the k from each term, because that's the common factor. So it's going to be c sub k plus 1 times k plus 1 times k minus c sub k plus 2 times k plus 2 times k plus 1 minus c sub k times k plus c sub k. And all of this is multiplied by x to the k. Then we have minus 2c2 plus c sub 0 equals 0. And now x to the k, if all of this is supposed to be equal to 0, then x to the k can never equal 0, and that means that all of this must equal 0. And then these two also will contribute to this entire sequence sum being equal to 0. So let's just write the inside of this equal to 0. C sub k plus 1 times k plus 1 times k minus c sub k plus 2 times k plus 2 times k plus 1 minus c sub k times k plus c sub k equals 0, and that's for all values of k starting at 1, going to 2, going to 3, and then on to infinity. And then the second equation is minus 2c2 plus c sub 0 equals 0. And let's solve for c sub 2, which means that c sub 2 equals c sub 0 divided by 2. And now these two equations are going to be c sub 2 equals c sub 0 divided by 2. And I'm going to box that one up because that's going to be something that we use from here on out. Now for this equation, we're going to solve for the c sub k that has the highest value. So in this case, when we plug in k, we have c sub 0, or plug in k equals 1, c sub 1, c sub 1, c sub 2, and c sub 3. So we're going to solve for this term with the highest sub value of c. So let's add c sub k plus 2 times k plus 2 times k plus 1 to both sides. C sub k plus 2 times k plus 2 times k plus 1 equals c sub k plus 1 times k plus 1 times k. I'm going to factor a c sub k out of here. So then I've got plus c sub k times 1 minus k, because I took a c sub k out of here. Equals, that doesn't equal anything, that just equals each other, because I added a plus c sub k to 2 to both sides. And now we solve for c sub k plus 2, so it's going to be this term divided by k plus 2 times k plus 1. And now for here, we have the same notation for k equals 1, 2, 3, all the way up to infinity. And now for here, I learned a trick from my math professor on YouTube. Well, he's not my math professor, but he's a math professor on YouTube. His YouTube channel is called The Math Sorcerer, and I learned all of my differential equations so far from him and from the book that I'm reading. And he's a great math professor, and he's the one who's pretty much my watch for the majority of the homework that I've done so far. And he taught me a trick that I'm going to use here. you can watch his differential equations playlist. His YouTube channel is called The Math Sorcerer, and he has a differential equations playlist, which you can watch to kind of learn the tricks that I'm going to use here. So I'm not really going to go over the trick, I'm just going to do it. So we're going to solve for the first y1 solution, the first solution, y sub 1. In order to solve for y sub 1, we're going to say to find y sub 1, choose c sub 0 equals 1, c sub 1 equals 0, and c sub 2 goes according to these values that we have here. So c sub 2 is going to equal c sub 0 over 2. C sub 0 is 1, so c sub 2 equals 1/2. Now, make sure that's a distinct y1, that's not a comma. To find y1, choose c sub 0 equals 1, c sub 1 equals 0, and c sub 2 equals 1/2. And now we start plugging in values and start looking for a pattern. So k equals 1. We're going to say plug in k equals 1 to here. So it's c sub 3 equals c sub k plus 1, which is c sub 2, times k plus 1 times k, which is 1 plus 1 times 1, which is 2 times 1, or 2, plus c sub 1 times 1 minus 1, which is 0, and then divided by 1 plus 2 is 3, times 2 plus 1, no, 1 plus 2 times 1 plus 1 is 6. And then we plug in the values for c sub 1, which is 0, but it's already going to be 1 minus 1, which is 0, plus c sub 2 times 2, which is 1/2 times 2, which is just 1. So c sub 3 is 1 over 6. And now I'm going to erase this. I don't need this anymore. I'm also going to erase this. I'm also going to erase this. So now we have c sub 3. So let's plug in k equals 2. So we have c sub 4 equals c sub 2 plus 1, which is c sub 3, times 2 plus 1, which is 3, times 2, which is 6, plus c sub 2 times 1 minus 2, divided by 2 plus 2 is 4, times 2 plus 1 is 3, equals c sub 3 is 1 over 6, so that's going to be 1, plus c sub 2, which is 1/2, times negative 1, which is minus 1/2, and then 4 over 3 is 12, so we have 2 over 2 minus 1 over 2, which is 1 over 2, divided by 12, which is 1 over 24, and that is c sub 4. And I believe that that is 3 factorial and that is 4 factorial, because 4 times 3 is 12, times 2 is 24, so yeah, that's 4 factorial. Let's keep going to k equals 3. C sub 5 equals c sub 4 times 3 plus 1 is 4, times 3 is 12. That is c sub 4. plus c sub 3 times 1 minus 3 divided by 3 plus 2 is 5 times 4. So c sub 4 is 1 over 24 times 12, which is 1/2, plus c sub 3 is 1 over 6 times -2, which is -1/3 over 20. So we have 3 over 6 minus 2 over 6, which is 1 over 6 times 1 over 20, or 1 over 120. And that's a 5 factorial, because 5 times 24, let's see, 24, 48, 72, right? 72, 96, that is 5 factorial. So I think that's enough. So y sub 1 is going to be c sub 0 plus c1x plus c2x squared plus c3x cubed plus c4x to the 4th plus c5x to the 5 plus ... So we can write this as y sub 1. I'm going to write this down here because I'm anticipating having to write other stuff. So I'm going to write it down here. Y sub 1, c sub 0 is 1. C sub 0 is 1. C sub 1 is 0. C sub 2 is 1/2. So it's x squared over 2. C sub 3 is x cubed. Oops. X cubed over 3 factorial plus x to the 4th, c sub 4 over 4 factorial plus x to the 5 over 5 factorial plus ... And that's y sub 1. I just erased that. I just erased the equation that I needed. I need that. C sub 2 equals c sub 0 over 2. C sub k plus 2 equals c sub k plus 1 times k plus 1 times k plus c sub k times 1 minus k over k plus 2 times k plus 1. For k equals 1, 2, 3, ... And now let's try and find y sub 2. So we're going to choose c sub 0 equals 0, c sub 1 equals 1, and c sub 2 equals 0. So k equals 1. We have c sub 3 equals c sub 2 is 0, plus c sub 1 is 1 times 1 minus 1 is 0. So c sub 3 is 0. K equals 2. We have c sub 4 equals c sub 3, which is 0 times this, plus c sub 2, which is 0 times that, which again is 0. K equals 3. C sub 5. Again, we have c sub 4 times c sub 3. Both of these are 0. So we see that c sub 5 is also 0, and that's going to continue on forever. So we only have c sub 1 equals 1, which if we plug that into this equation, y equals c sub 0 plus c sub 1x plus c sub 2x squared plus dot dot dot. C sub 0 is 0, c sub 1 is 1, c sub 2 is 0, and so on forever. So y sub 2 equals 1 times x, so y sub 2 is simply x. And now, the general solution, when we combine both y sub 1 and y sub 2, we have y sub y equals c1 times y1 plus c2 times y2. Those are big C's because they're different than these C's. Equals c1 times 1 plus x squared over 2 factorial plus x cubed over 3 factorial, x fourth over 4 factorial plus dot dot dot, plus c sub 2 times x. And now we have to plug in our initial conditions to find the solution. So let's differentiate this. Y prime equals, well, c1 is going to be a constant which hangs out in the front, so we don't have to worry about that. 1 goes away, x squared over 2 factorial becomes x over 1, or x. X cubed over 3 factorial becomes x squared over 2 factorial. And then x to the 4th over 4 factorial becomes x cubed over 3 factorial. Plus dot dot dot, forever and ever. And then c2 just becomes c2. So now we're almost done, and we can plug in the initial values to find our general solution. Well, not the general solution, but the solution of the differential equations with the initial values. And I erase the original equation. Y equals c1 times 1 plus x squared over 2 factorial, x cubed 3 factorial, x to the 4th 4 factorial plus dot dot dot, c2x, y prime equals c1 x plus x cubed 3 factorial plus dot 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 plus c2. Now when y equals 0, when y of 0 equals -7, that means that we have -7 equals c1 times 1, and then all of these terms become 0 at the end of the dot dot dot, and then c2 times x, when x is 0, goes away, which therefore means c1 equals -7. Y prime of 0 equals 5, means we have 5 equals c1 is -7, but all of these terms are 0, so it's going to be 0 plus 0 plus 0 all the way. 0 times -7 is 0, that goes away, plus c2 is 5, which means our final solution, final answer, is c1 -7. I'm going to distribute it to all of those numbers. Actually, I'm not, because then that means I have to find out which one of these the only term it's going to actually make every other term past 6 factorial is going to be having a 7 canceled with it. So I suppose it doesn't matter. Whenever you enter it in webassign, it's going to accept the answer most likely either way. Plus 5x, and that is the final answer. So that's how you solve a differential equation using, or let me consider something real quick before we stop. X equals 1 is a singular point. So if I plug in 1 into this equation, what's going to happen? I have 1 plus, that adds up to 1 plus, I think, 1 over 2 plus 1 over 6 plus 1 over 24. I think that's, I don't know what happens there. But I hope that's not part of the answer. But if you watched this far, that's how you solve the equation. Thank you for watching.